Hello. Okay. So in this session, we are going to discuss uh, chain code or the smart contract that we write in the GoLang. Okay. We will see what all interfaces you need to implement and how we can write a smart contract in the GoLang. Okay, so and I would also recommend or suggest to go through some GoLang tutorial before you watch this video because you need to have some basic understanding of GoLang programming language or the Google programming language. Okay, but I will not go in the details of Google Golang programming languages or its syntax, but I will only focus on the methods or the things related to uh, smart contracts that we need to use to write a smart contract or the uh, chain code in the Hyperledger fabric. Okay, so this is the in my Eclipse I have installed the GoLang plugin. Okay, and once you install the GoLang plugin in your Eclipse, you will able to create the GoLang project. Okay, in this GoLang project, I have created a hello world .go program for our for for to demonstrate smart contract functionalities to you. Okay, so uh, first thing is when you write any Go program, right? You have to import the packages or the classes that you want to use in your program. It's very much similar to import statement in the Java language. Okay, so this is the import statements, and these are the packages that we need to uh, write a smart contract, at least on the very basic level. Okay, now Fabric framework uh, asks ask you to implement an interface called the chain code. Okay, chain code is interface defined in the Golang shim package, and if you want to write a smart contract, you have to implement the J code. Sorry, you have to implement the chain code interface. In this interface, we have two methods. One is called init, and another is called invoke. And as you can see, I have implemented these two methods in my class in this GoLang file. Okay, so what is the init and what is the invoke? You have seen we initialize our chain code. First, we deploy the chain code, and after the deployment, we initialize the chain code, right? So, we instantiate the chain code after the deployment. So, when you instantiate the chain code, and remember, you instantiate the chain code only and only once. Okay. So, when you instantiate the chain code, your Fabric framework invokes init method. Okay, it invokes this init method, right? So because you instantiate your chain code only once in the life cycle of the chain code, so this init method will be invoked only once. Then we have another method called the invoke. Invoke method will be executed by the Fabric framework every time you or your user initiates a transaction. That transaction can be query transaction, or it can be an update, delete, or add transaction. Okay, user want to add something to the ledger. User is trying to update something in the ledger, or user is uh, user want to delete something from the ledger. So every time for those transactions, invoke method will be executed by the Hyperledger Fabric framework. Okay, so this method gets executed every time when a transaction is processed by your user. Okay, so chain code is an interface, right? Chain code is an interface. In GoLang, we have a concept we have a concept of interfaces, and we have also a concept called the struct. This struct. Okay, so struct is nothing but a data type in the GoLang, right? And in GoLang, struct is used to implement chain code, implement interfaces, right? So because chain code is an interface, we will be using struct data type to implement the chain code interface. Okay, so we will be using struct data type of the GoLang to provide the implementations, to implement the interface, or to provide the implementation of methods that has been defined in the chain code interface. So this is you can see this is how I have defined my struct data type. Okay, this is the name of struct, and this is the key. Struct is a keyword, and the type is also keyword. So in this interface, or in this definition of struct, uh, in this definition, you can define data types, or you can define a kind of instance variables. Okay, so if you have your implementation requirement says that we need to use couple of instance variables that should be used in across all the methods in the chain code, then those variables can be defined here, right? And these variables will exactly behave like your instance variables in Java classes. Okay, next, how we define the method of an interface. As I explained, chain code interface has two methods: init and invoke. So now it's the responsibility of your hello world struct data type to provide the implementation of these two methods. So now this part is little different than how we implement the interfaces in the Java. Okay, So in the GoLang, we write function keyword, okay, to define a function basically, okay. But if that function is implementing an interface, okay, then you have to pass the you have to use this syntax, right, that determines that this structs want to implement an interface that has a init method. Okay, so hello world, which is as you can see, in this hello world we are passing an uh, pointer or the reference variable. Okay, so this hello world t variable take a reference of uh, hello world uh, hello world struct type object. Okay, so here you can see how we are using it. Then we have init method, uh, which is which we want to override, right? And this init method takes an argument of type chain code stub interface, takes an argument which is of type chain code stub interface. Okay, chain code stub interface. And so here the variable, uh, name of variable which is of type chain code stub interface is stub. Okay, so init method, and this is how init method is declared in the chain code interface, right? So we have to use the same uh, uh, declaration. Okay, so the init method that which is defined in the chain code interface, it takes an argument of type chain code stub interface, and name of variable which is of type chain code stub interface is stub. Okay, and the return type of this method is response. Okay, return type of this method is response. Okay, so this is how we override and method of an interface in the GoLang, right? So in this init method, you will be writing your initialization code. Okay, now what you will write here, how you will write here, that will be determined by your requirement and the kind or the kind of initialization you want to do for your application. Okay, so in my case, I have just use fmt.println statement. So this statement will just print this string value in the console, just and uh, this value is here for me just for the debugging purpose, right? Because I want to show my people that this method is invoked, and this method is invoked when you instantiate the chain code after the deployment. Okay, then on this system, uh, variable which is of type chain code stub interface, you can call put state method. Okay, and this method interface interfaces your program with the chain code ledger. Okay, with the chain code ledger. So when you will be calling this method, or you will be invoking this method to store some value in the in the ledger. Okay, so stub dot put state, so you will call this method to store some value in the ledger. Okay, this method takes two arguments. First is a key, and other is and the second argument is value, right? So key and value. Key is of type string, but the value is uh, array of bytes. Okay, so value of this second argument is byte array, and the reason behind this reason behind this argument to make the byte array is that against a key you can this byte array argument allow you to store anything, right, against a key, right? So you can store an image, you can store a PDF file, you can store JSON string, you can store XML, right? So this making the second argument as a byte array has given you all this flexibility that allow you to store any kind of any kind of uh, value or data in against a string in the ledger. Okay, so this is stuff dot put state. Okay, this is the key, and the second argument is the value, right? Put state method returns uh, it can return an error if something went wrong while updating the ledger. Okay, then it can return an error. So this is here you can see that put method can return an error variable, and which I am storing on this err1 variable, right? And if you see here, this is a special syntax in the GoLang that allow you to create a variable without declaring that variable. Okay, so this is the syntax that I'm using here to assign the error that may be written by the put state. So in the next statement, I have checked if error is not nil. If error is not nil means put method has written some error or it has failed to update the ledger state. So this is the what I'm doing here in the init method, right? At the end, as you can see that in the signature of init method, we need to return a we need to return object of type response, right? Object of type response. So I'm calling shim dot success method to return the response object. Okay, so if you want to pass some value after execution of init method, then you can pass it here. If you do not want to pass anything, you can just make it as a nil, right? And whatever you will pass here, you will able to get it on the client side in the payload or in the Java program as a payload, response payload. Okay, so this is the init method. Next, let's look at the invoke method. So this is another method which is declared in the chain code interface, and now because we are overriding chain code interface, we have to provide the definition to this method as well. Okay, so we have to override, or we have to provide the definition uh, of this invoke method as well in my file, because I'm overriding the chain code interface. So the first, we have to use the keyword func function, and then the struct type that want to override this method. Okay, And here again, same as we had in the init method, here also we are passing um an argument which is of type hello world. Okay, and this is an pointer reference. Okay, this is a pointer, right? And then we have invoke method, and this method also takes an argument of type chain code stub interface, and name of variable which is of type chain code stub interface is stub. All right, and the return type of invoke method is same as we have in the init method, which is of type response. Okay, then I have this println statement just for the debugging. Now here is another important method, stub dot stub dot get function and parameters. Okay, stub dot get function and parameters. Okay, get function and parameters. This method, which is defined in the chain code stub interface, returns name of the function that that your user want to invoke and the argument that your user has passed, which means let me show you add to ledger, say suppose. Okay, so when we invoke a transaction, right, we create the transaction proposal request, and in the transaction proposal request we set these two parameters, or we invoke these two functions. Set function as invoke, and this is the argument list. Okay, first value hello world, right? And you can see here in this method we are passing a string array argument, right? So these two variables, okay, or these two values will be accessible inside the chain code, okay, inside the chain code using this function. Okay, get function and parameters. Okay, and in GoLang there we have a arrangement or the feature that a function can return multiple values. Right, a function can return multiple values, and I believe this thing is not directly available in any other programming language like Java or C++. Hmm. So we call get function and parameters. Okay, this get function and parameters method returns name of the function and the argument that has been passed by your uh, user who has sent the transaction, or the transaction proposal request. Okay, and this method because it has multiple values, so I have used two parameters here. Okay, and here you can see that again I have used this special syntax that allow me not to define the, or sorry, not to declare the variable or the variable type. So here the first argument is the function, right? So name of the function that has come in the transaction proposal request will be available in the function variable, and the list of arguments that has come in the transaction proposal request will be available in the ARGS. Okay, and because if you can see here I haven't declared these two variables, right? Because in GoLang if you use this special syntax, then you don't need to declare the variables. Variables type of the variable will be automatically considered as the returned value from this function. Okay, so the function uh, GoLang will automatically consider or make function as of type string, and the args, which is the argument, will be considered of type string array. Okay, it will be considered string array. Okay, so just to validate this fact here, I just printed function and the argument 0, right? And if you want, I can also print the argument uh, 1, which is available in the string array. Okay, so the function name, argument 0, argument 1. Okay, now as we have only one method called the invoke, which will be executed every time uh, your client sends a transaction proposal, whether it's a query transaction or it's a update, add, or delete transaction. Okay, chain code fabric network of peer fabric APIs in which is running in the peer will always invoke this invoke method, right? So to perform different operations based on the requirement, we have to make the decision, or we have to perform different activities based on the function or name of the function that your client want to invoke or your client has passed in the transaction proposal request. Okay, so here I check what value is stored in the function variable. If the value is invoke, okay, then I call t dot invoke method. It means I want to call another method which is part of my hello world struct. Okay, and if value of function is query, then I will consider that user want to query something in the ledger. He want to fetch some value from the ledger. And in case of the invoke, my consideration is he want to add or update something on the ledger, right? So based on the values in the function, we can invoke different operations in the chain code, right? And you can have n number of functions defined, like deposit, cancel check, or update account number, and so many other things, right? So based on the name of function that has come in the transaction proposal request, you will able to perform different operations on your ledger, and you will able to perform different you will able to invoke different functions in your chain code. Okay, so let's look at the invoke function and the query function. Here's my invoke function, and this function, in this invoke function, or this query function, right? It is not the part of your chain code interface, and the name of these functions could be anything, whatever you want. Okay, uh, I have written it invoke. You maybe you when you will create your smart contract, you will be writing as a put or get. So it's up to you. Okay, and the what parameters you will pass, what parameters this function will take, again it will be determined by you. Okay, so just for to explain this in an easy way, uh, I have defined my invoke function means I with a small letter. I define this invoke function to take chain code stub interface and the string array argument. Okay, string array, uh, I mean string array argument, right? As you can see here, right? And actually it was not necessary for me to define a string array argument here. And the reason behind that, when I have stuff here in the method, I can invoke the same method again, right? Get a function and parameter, right? So to get the name of the function and the string array argument that has been passed by the client, right? So this was not required, or in fact, uh, yeah. Okay, so now you will implement maybe in a much better way than what I have here. Okay, but because this is just to demonstrate that how chain code works, so that is why I have this arrangement. Okay, so this is my string array. So from this string array, I have retrieved key and value uh, that your client has passed in the transaction and want to store in the ledger, right? And so agreement between the chain code and the client program is, first argument has to be the key and the second argument will be the value. Okay, and remember, this value can be anything. It could be a JSON string, it could be an XML string, or it could be a PDF file as well. So I got the key and value. Then in the next statement, I executed the get stuff, get state method on the stub. Okay, on the state stub variable, which is of type chain code stub interface, I call the get state method. Okay, and get state method is another method which you can invoke on the chain code stub interface to retrieve, okay, to retrieve values from your ledger. Okay, so say suppose you have some value stored in the ledger, and obviously value is stored against a key, right? So if you want to get the or retrieve the value of that key from the ledger, then we call the get state method. So get state method takes one argument which is of type string, and this string value should be a key. It should be a valid key. Okay, it should be a valid key in the in your ledger. So get state method returns get state method returns value, right? Which is stored against this key in the ledger, and if it fails to retrieve that value, it returns the error. Okay, it returns the error. Okay, you can see here like that. Okay, byte, it return type of get state is byte and error. Okay, so byte is value that is stored in the ledger against this key, but if it fails to retrieve this value because of some reason, then it returns the error. Now this is the another syntax, right? This is another syntax in the GoLang that you can use to write a quick test in your program, right? So if this syntax means I do not want to use and store the second argument, right? Otherwise, I mean, I have to write something like this. Okay, and if you now in GoLang, there is another property or feature that force you to use the variable if you have declared it, right? So here if I say like this AAA, right, then if in case of any error, error will be stored in the AA variable. But now I have to use this AA variable somewhere in the program, right? If I do not use it, my chain code will not be, or my program will not be compiled. So if you do not want to do that, if you know that you will never get an error, which is very unlikely, right? And due to some reason you just do not care return value of that variable, then you can use this syntax to skip that hassle to declare a variable then and then use it in some way. Okay, so this is the special syntax in the Golang. And so this is where you will get the return value against init key from the ledger. And as you know, in when we use the put state, when we use the put state method, we pass the byte array, because in the ledger everything is stored as a key and value is the byte array, right? So when you are retrieving, right, from the ledger, you will get a byte array, right? So this is the byte array. Data type of uh, value 2 is the byte array. Okay, so that is the reason you can see here when I printed value of value 2 variable, I had I have to convert that byte array into string. Okay, and so this is how you can retrieve a variable from the ledger, or a key from the ledger. Next, I invoke this put method again. This put method is same as we use the put method in the init method. Okay, so put state, this is the key, and this key is has come from the client in the transaction proposal request, and the value, and you can see here I'm converting value into the byte array like this. Okay, so in the next statement, I have checked if there is any array, if there is a error. Okay, so if there is any error written by the put method, so if there is any error, I return the error message to the client that that due to some reason ledger is not updated, and the reason of not updating the ledger is this error one dot error. So I invoke the error method on the error object, right? But if everything is successful, then shim dot success nil. Okay, so this is how I am saving or storing a key value in the ledger. Okay, so this is the implementation of invoke I small function in your smart contract or the chain code. Now, I mean, when you will implement this method, invoke method or the put method, maybe in your case, you will be writing your definition, and I believe it will be much more complicated than this. Okay, so now let's look at the query method. Query. So again, uh, this query method is not part of chain code interface. Okay, it's not part of chain code interface, so it's all up to you that how you want to define this method. Okay, and how you want to declare this method. So if you see this time, I I did not mention array string array argument in the parameters. right? um, I use only chain code stuff interface. So this query method take only one argument, which is chain code stuff interface, which is of type chain code stuff interface, and the name of variable is stuff. Okay, and this method returns response object. Okay, and because I want this method to be part of hello world struct data type, that is why I have used this syntax here. Okay, now the first thing is, again I'm using calling this method on the stuff variable get function and parameters, which returns the name of the function and the array argument. Now again, if you see here, I'm skipping to store the name of the function, because I want to name a function in the invoke method, because based on that I will know which method client want to invoke. But now when I am in the query method, I don't care what is the value of the function. So by writing this underscore here, I skip the handling or storing the first argument, which is written by this method get function and parameter. Okay, so here is my arguments args. If so, again here I have a if condition, because if you want to do a query, right, it is mandatory that you pass at least one argument. So length of your argument array should be at least one, right? It should have at least one parameter, right? So if this condition is not met, then a res- error response will be sent. Okay, an error response will be sent to the client. Okay, and the message will be this incorrect number of arguments, arg0 should be item barcode, right? So this is the message that will be sent. So in next statement, as you can see, I retrieve the first element of the string array, which I stored in the key variable, which is again type is not declared, and now you know the reason, right? Because I'm using this special syntax. Okay, then I use this key variable to retrieve the value of key from the ledger. Okay, and the retrieve value is stored in the value parameter, right? And then just because I wanted to print this value to make sure that the right value has been retrieved or some value has been retrieved, I have this debug statement here. Okay, and after that, this time because I wanted to return something to the client. Okay, so that in the your client see value of the key in the payload of the response. So I call this method shim.success and the value that I want to pass as the payload So value written by the get state has been returned to the client using this method shim.success value, right? So this is how we can write a uh, simple smart contract or chain code to interact with the ledger. Okay, another important thing is main method. Okay, so function and the name of function main, right? As in the Java, all program starts execution from the main method, right? A main method which takes the string string type array argument and returns void, and which is public and static. So that is the syntax for the main method which your JVM executes at the start of your program. In the same way, in the GoLang also, in GoLang also we have in GoLang also we have main method. Okay, so your uh, Go starts execution from the main method. Okay, Go starts execution from the main method. So in this main method I have done nothing but just to start the chain code or the smart contract. Okay, to start the smart contract, we need to call a method called the start on the shim interface, shim class. In the shim class we have a method called the start, which takes an argument of type chain code. Okay, now remember, to start the chain code or the smart contract you need to call the start method, which is defined in the shim class. Okay, start method takes an argument or takes an object of type chain code. Now, chain code is an interface, right? But in this GoLang file, I have implemented I have implemented chain code interface through the struct data type, right? And the name of that struct is hello world. So this hello world class is implementing chain code interface. So by the rule of the polymorphism, I should able to pass child class, right, which is my hello world in the method which take the argument of parent type, which is chain code. So because of that, I created a new hello world. I created an object of hello world which is implementing the chain code interface, and pass that object in the start method. Okay, pass that argument in the start method. So when your GoLang executes this, uh, uh, it executes this method, your chain code gets started. Okay, and again here I check for the error. If there is any error, then I print this message on the console. But if there is no error, main method will end. Okay, and you can imagine or understand this start method is like your thread.run, right? To start a new thread, right? To start a new thread we call the thread.run, right? So that starts a new thread. In the same way, to start the smart contract we need to call the shim.start, and in the start method we need to pass an object of type chain code. Now because hello world implements the chain code interface, pass I have been able to create an object of hello world and pass it in the shim.start method. Okay, okay, so now we understood that how we write the smart contract and what is the basic building blocks of writing a smart contract. Now let's run this smart contract. Okay, so we have to first bring up our network. Okay, so network is up. I will go here. Okay, so first we have to create a channel. Okay, so uh, my channel has been created. Next step is uh, I will ask my first organization to join the channel, and we have discussed all these things multiple times, so I'm not going to repeat that. Okay, first organization joins the channel. Now I'm going to use my second program that will let my second organization to join the channel. Okay, so both organizations have joined the channel. Next, this is the step, okay, where I will deploy my smart contract or the chain code in the on the peer. Okay, so when I run I have explained this program, right, in the previous session. So when I run this program deploys the smart contract or the chain code on the first organization. Okay, I'm running second program. This will help me deploying the chain code in the second organization. Okay, so my chain code has been deployed on both organizations. Next, I'm going to instantiate chain code. To instantiate the chain code, I will be running this program, right, that I explained you in the previous session to instantiate the chain code on both organizations. Okay, and you know that if chain code instantiation is successful, then we should see two more containers in our network. Okay, because chain code or smart contracts run in a separate container by the peer organization or by the peer container. Okay, to make sure that I will open another command line console, and I will run this command. Okay, docker ps. So you can see here two more containers has been created. Okay, so one container is created by organization 1, and other container is created by the organization 2, because this is we deployed our chain code on the organization 1 and organization 2, and we send the initialization request to 1 and first organization, and as well as to the second organization. So both peers where chain code was deployed, when we initialized, those peer has created separate containers, right? So these we have these two containers which are running the chain code. Now, to see the console of these containers, okay, or to check the logs of these containers, you can use this docker command that I'm writing now, docker logs, and the ID of your container. Okay, so you can see here, right, when I execute this command, I can see in main method and then in init method. If you go and check in my GoLang program, okay, I have printed this statement asterisk 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 and then in main method, in the main method. So if you see this in the console, it means somebody has called this main method, right? Somebody has called this main method. So it indicates that your main method is called, and your main method is called by your fabric uh, application when your peer has created the new container and started the smart contract. Okay, and after running the main method, because we initialize the chain code, we instantiated the chain code, and when peer gets the uh, instantiation transaction, it invokes the init method of your smart contract. So your init method is also called, which is defined in the chain code or the smart contract. So if we go in the hello world.go chain code, you can see here init method, right? You can see here init method, and inside this init method I have this statement, right? This println, right? So if this println, if we see this in asterisk asterisk in init method message in the console, it means init method was invoked, right? So it indicates that init method was invoked. That is why you see it here, right? Similarly, if you see the console of second container, you will see the same value here, because chain code was initialized on both peers. Okay, so this is how it works. Now let's add something in the ledger. So to add a value in the ledger, we have this client Java program that and the name of class is add to ledger, right? So and I have run this program, and I have explained everything whatever is defined in this program, right, in previous session. Okay, so so what happened? I send a invoke transaction. Okay, and this invoke transaction was sent on the organization one, right, in the organization one. So container that is created by the organization one is this. Okay, so if I see the log of that organization, you can see here, after in main method and in init method, we have hash 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 inside invoke method. So where it is? Inside invoke method, right? You can see here inside invoke method. Got it? So here is your inside invoke method. Then function name, argument, and the argument 0, right? Okay, this method is not printed because I deployed the old version of the chain code. Okay, because I deployed the old version of chain code, not the new version. So that is why this argument is not printed here. Okay, but you can fix this problem easily. Okay, so here is your function name. Function name is invoke. Argument 0. Argument 0 is printed here, and argument 0 that is passed from the client is first value. So you can see here first value, right? Value retrieved from init value. Okay, where that statement is mentioned, you know that in from the invoke method we call the invoke method with I capital, with I small. Okay, so this method is invoked. Value retrieved from init value. Okay, so value retrieved is printed because of this println, this string constant here, right? And after that we have init value. So this value is printed. Okay, string value 2. Okay, value of variable value 2. Value 2 stores value 2 stores the uh, result written by the get state init key, and the value of init key was stored when your chain code was initialized, and the value was stored as a init value. Okay, so that is the reason you see this statement here like this. Okay, and then we have hash hash state value saved successfully in the ledger. Now where this is mentioned, here it is. Okay, state value saved successfully in the ledger, hash hash hash, right? And this is your invoke method. So it indicates invoke method has been invoked. Okay, but if I see in the container, in this another container that is created, you will not see invoke method invoked here or executed here. Reason behind that is you send the transaction proposal request only to peer of organization 1. Okay, if we had sent the proposal request to both organizations, okay, then invoke method would have executed on both containers, right? Now let me run the same program again. This time I will change the value of the first value to second value. Okay, okay, come over here. So again, method is not invoked on the second peer container, okay, second organization's container, but it is executed in the first uh, peer's container. Okay, so you can see here this same debug statement is repeated again, but this time arg0 is second value. Okay, arg0 is second value. This is the name of your key. Okay, you can also notice that you can also notice here that init method is not invoked again. Okay, because init method is invoked only and only once when your chain code is instantiated. Okay, init method will never invoked again, right? Now let's send a query transaction. Okay, if you see in the program, right, that I explained you yesterday, and I'm also going to provide all these Java programs and the GoLang program. Okay, in the query ledger program, I send the query transaction to organization 2, second organization. I send the add transaction to first organization, but I send the query transaction to the second organization, right? And this program has run, and I explained this part to you in the very beginning, right? This indicates that orderer has sent the same transaction endorse transaction proposal request to both the peers, right? So because of that, ledgers of both organization has same values, same data. Okay, and that is the advantage of your blockchain network and the distributed ledger. All right, now I'm going to query the ledger of node or second organization. Okay, ledger of second organization. So if I run this program, right, uh, what you will see invoke method is invoked or executed in the container of organized second organization 2. Okay, query method is not invoked on the first organization's container, right? And first of all, see, we have get the correct value, which is your hello world. You can see here, right? Similarly, okay, Docker, yes, okay, 819. This is the container ID of organization one. Okay, so here you can see in this container invoke method is sorry, query method is not invoked. Okay, why I'm saying query? Because the while running this program, we pass the argument name of function as a query. Okay, so that is not invoked here. But if I check the log of my container, which is started by the second organization, you will see invoke method is invoked on the on that container, on that chain code, on that smart contract. Okay, so here you can see, right? All right, see, inside the invoke method, and then the function name query, arg0 is the first value, and the value retrieved is hello world, right? If I query for the, if I pass the second key, right, uh, value is actually same, so it will not make any difference. But we will see that query method is executed again. Program is still running, right? See, you will see this. You can see this debug statement twice in the console. And why it is? Because we run the query method twice, and you will see this uh, debug statements only in the container of the chain code of the second organization, not the first organization. See, right? So now I hope you understood that how we write the chain code and how smart contract works. Okay, so that's it for today's session. Um, okay, thanks.